This is AP Review 2.5, 2.6, number 15. Part A asks us to verify that dy dx equals that using implicit differentiation. For the most part, I think we're doing really well with that. If you have questions on Part A, let me know, and I'll put a video together for that part. Part B, write an equation for any horizontal tangent lines. Horizontal tangent lines occur when the slope is 0. So for Part B, we're going to set dy dx equal to 0, which means the top is 0. Once I get x equals 0 on the top, you always need to go back and plug that into the original equation. So that's going to give me y to the 4th equals y squared minus 0. Solve it by getting it equal to 0. Factoring out a y squared. And solve. So I get y equals 0. We get y equals 0 or y equals plus or minus 1. I don't know why it keeps doing that, but y equals plus or minus 1 is correct. Y equals 0, notice when x is 0 and y is 0, we get 0 divided by 0, which technically isn't 0. It's undefined. So this one's not technically a horizontal tangent line. I wouldn't worry too much about that. Y equals plus or minus 0. If you included this, that's fine. Part C wants us to write an equation for any vertical tangent lines. Vertical tangent lines occur when the slope is undefined. So we set the bottom of the slope equal to 0. Again, we need to factor. We get y equals 0. We get y minus 2y squared equals 0. 1 minus 2y squared. So we get y equals plus or minus the square root of 1/2. Again, we then need to take this and plug it back into the original curve, which is way up here. If I plug in y equals 0, I get 0 equals x squared. I get x is 0, which again, for the same reason over here, we get 0 over 0, which is not horizontal or tangent, or not horizontal or vertical tangent. And then plug in this. So square root of 1/2. So if I plug that in, square root of 1/2 squared equals, or to the 4th, equals square root of 1/2 squared minus x squared. So if I square this, it cancels, and then square it again gives me 1/4. One half minus 1/4 is 1/4. We get x equals square root plus or minus 1/2. So our vertical tangent lines are x equals plus or minus 1/2. So again, the process there, if we're looking for a horizontal tangent line, set the top equal to 0, solve, plug it back in. Vertical tangent line, set the bottom equal to 0, solve, plug it back in.